Okay, so for this question here, it says find the range of values of x for which 2x minus 7 over x plus 3 is less than or equal to 1, where x is a real number and x is not equal to minus 3. Okay, so these are our rational inequalities, okay, because it's inequalities but with fractions. So what I'm going to do to start is I'm just going to rewrite out my question to make sure that when I start, I don't make any silly mistakes in trying to work from up here and then bring it down here at the same time as doing something else. Okay, now when I am going through inequalities, what was my main rule if I had an inequality? The main rule was that I treat them almost the same as my equations unless I multiply or divide across by a minus. Okay, so here I don't like the fact that there is a denominator here. Okay, I don't like the fact that there is a fraction. So what I'm going to do is I am just going to get rid of what's in the denominator. Now, if I do that, okay, how do I get rid of what's in the denominator? I multiply both sides by x plus 3. If I do that, am I multiplying across by a positive or by a negative? Because if I'm multiplying across by a negative, then the sign would have to change direction. So which am I doing? Is x plus 3 positive or negative? We don't know. Okay, it could be either. So if x was something like minus 4, okay, if x is minus 4, then this could be a minus 1 that I'm multiplying across by. And I don't know whether it is or not. So I don't know what I'm multiplying across by. So I don't know if it's positive or negative. So I don't know whether to swap the direction of the sign. So how could I make sure that what I'm multiplying across by is a positive? What can I do to make sure I am multiplying by a positive? What can I do to x plus 3 to make it positive? What could I do to something like 7 to make it positive and to something like minus 7 to make it positive? I could square them. Okay, so if I square what I'm multiplying across by, then I know I'm multiplying across by a positive, which means the sign stays the same direction. Okay, so one of these x plus 3's that's multiplying is going to cancel with the x plus 3 that's dividing. Over here, neither of them are going to cancel. Okay, so one of these in the squared is going to cancel with the denominator because it's dividing. And I'm still going to be left with x plus 3 by 2x minus 7. And that is less than or equal to 1 times, so I don't need to write out the 1 times because I know that's not going to change my answer. Okay, and then the x plus 3 by x plus 3. So let's do out this multiplication. Okay, the first bracket, I'm going to get 2x squared minus 7x plus 6x minus 21 is less than or equal to x squared plus 6x plus 9. Okay, now what does this look like if I was going to go and try and solve it? It's starting to look like a quadratic. Okay, now if we were going to solve a quadratic, we know that there has to be a 0 equal to it, or in this case with the inequality. Okay, so on the other side of the inequality, we want this to equal to 0. So how do I get rid of the x squared? How do I get rid of the 6x? How do I get rid of the 9? I'm going to minus them. So I'm going to minus x squared. I'm going to minus a 6x from the x terms. And I'm going to minus a 9 from the constants. So that on the right hand side of this, I have 0. Okay, on the left hand side, I'm going to have x squared Minus 7x plus 6x minus 6x is going to give me minus 7x. And then minus 21 minus 9 is going to give me minus 30. Okay, so there is my quadratic. Okay, there is my quadratic, and it's an inequality quadratic. So that means that I have to figure out where this quadratic is not just equal to 0, but where it's less than or equal to 0. So remember what we do in these situations. Okay, it's up to you if you want to draw the sketch first or find the roots first. That is completely up to you. If you were stuck and you had this, it probably would be your go-to to be like, well, I would know what to do if it was equal to 0. So I'm just going to do that. Okay, and funny enough, you actually do have to do that to get towards your answer. Okay, what are we doing though here? If I have a quadratic, okay, so if I have a quadratic like this, and I'm finding where it is less than or equal to 0. So where is it less than my x-axis or equal to my x-axis? Okay, well, it's equal to my x-axis at the roots. Let me get my another colour out here. At the roots, and less than it anywhere below that. So in all these points between them. So how could I figure out what that is? Well, if I figure out what is the value here, what is my x value there, what is my root, and what is my other root. So if I find my two roots, then I know that everything between those two roots is where it is less than the x-axis. Okay, now that wasn't always the case. Remember, if I had a negative quadratic, then it would look like a sad face. So then it would be less than equal to the roots. So it could be equal to the roots and less than the roots here. Okay, so there is sometimes that when we find the roots, it could be like, let's say this is something like minus 1. Okay, it could be everything where x is less than or equal to minus 1. And let's just say that this is 5. Everywhere where x is greater than or equal to 5. Okay, that's not the case here because I know it's a happy face quadratic because it was a positive quadratic that I had here. Okay, and likewise, it's below the x-axis because it's less than 0. If it was greater than 0, then I could be looking at these parts up here where it's greater than 0. Okay, so we always want to draw a sketch in. Okay, you want that sketch to be there. So leave that sketch there. The only things that I probably don't need to have in that sketch is these little question marks because I'll actually fill those in with the numbers when I find the roots. Okay, so I know that I am trying to find these x values here between my two roots. Okay, so I need to find the roots. So here is my quadratic, find the roots. So that means it's equal to 0 and we need to solve. Okay, so finding the roots is when it's equal to 0 and we solve. Okay, and this is a nice quadratic for me to quickly factorize because the leading coefficient is 1. Or you can use the minus b formula, it's up to you. Okay, but I know that I can actually do this out really nice and quickly as a quadratic by literally finding numbers that multiply to give me minus 30 and add to give me minus 7. Once I have those numbers, I just put x first in both brackets and then the two numbers in the bracket with them. Okay, so I have two brackets multiplying to give me 0. So let each bracket individually go to 0 and use those factors to solve the roots. Okay, so those are my roots. So on my sketch up here, I have minus 3 and 10 are my roots. Okay, so I didn't have to do that sketch so early on. I could wait and do it now. Okay, it's up to you, but you do want to do out that sketch so that you can kind of visualize, is x between the two roots or is it outside the two roots? Okay, was it a happy face quadratic or a sad face quadratic? Okay, so Now I know that it's meant to be between those two roots. Okay, so I'm going to go back to this quadratic inequality that I had, okay, because it was an inequality, not just an equals to find the roots. So it wasn't just the roots, but it's everything underneath that part as well. Okay, so I want to show that x is between -3 and 10. So see the way that's one connected line? So my quadratic is going to be my inequality is going to be one connected inequality, where x is, and I'll come back to this in a second, but for the moment, we copy the sign down from what was here. Okay, so where x is greater than or equal to -3 and less than or equal to 10. Now, I said we'd come back to this one in a moment, because let's go back and reread the question. Okay, it says, find the range of values for x, for which 2x minus 7 over x plus 3 is less than or equal to 1, where x is a real number and x is not equal to -3. Okay, now that most of the time, that means that just the denominator won't be 0, but it does affect our answer here. X can't actually be equal to 3. So we're actually not, the -3, sorry. So we're actually not going to include the -3. Okay, now we do want to include -2.999999999, but we don't want to include -3. So how can I exclude that? Well, I'm going to change that part of the inequality so that it is not equal. Okay, but it still can be less than or equal to 10. So if I actually looked at that as a quadratic sketch, again, okay, I would want it to have, so here is -3 and here is 10. Okay, x can actually be, x can be 10. Okay, so that it's equal to 0. X can be 9.99999. And for all these ones, it's going to be less than. But right here, it is not able to be -3. Okay, so we never have to sketch them out like this in the quadratic, but that kind of is what we're doing here. Okay, this is as much as we need to do in the quadratic, but essentially here we're just excluding the -3 itself and getting everything else underneath the quadratic included. And I'm going to rub that out so that when you guys get the PDF version of these, you won't be confused by that. But that is it.